Hey, I'm Thomas and this is day 22 of 100 Days of Code in IoT Challenge. Today I'm gonna show you how to turn your ESP8266 into a web server working on your local network. That is one of the crucial IoT functionalities of ESP8266 that allows you to control any module or component connected to the microcontroller through the web interface that you can upload from your computer. But enough talking, let's move to the code and start a new project. Okay, so we're going to start from creating new project with PlatformIO. So I'm gonna go to PlatformIO Quick Access, Open, and then new project, and let's call it Web Server. Web Server. Board is Node MCU 1.0, framework Arduino, default location. Finish. Cool. Okay, the project is created and yeah, platformio.ini opened. First step, as always, is to define monitor speed so we can communicate with our IDE through the serial port. So now I'm gonna go to main.cpp and set the exact same value as a value passed to the begin method of serial static class. Okay. So that's it for the first step. And now before I start writing the code, I need to install my library to connect to Wi-Fi. It's, essentially in order to serve static files or have any endpoint with your web server, for me to be able to call those endpoints from my browser, for example, or Postman, the device needs to connect to the internet, needs to connect to Wi-Fi. We're doing it on a local network today, so we need Wi-Fi connection. And to connect to Wi-Fi, I'm gonna use my own library. Let me just quickly clone it. You can find the link to the GitHub of the library in the description of this video. But essentially what I need to do is to go to the lib folder and then just run git clone into a core directory. So that's going to automatically create a core directory inside a lib directory, the directory for the library, for the internal libraries. Okay, so I've got this done. My core library, for those who don't know, it's just a set of tools to handle non-blocking coding with ESP8266. I also have, some utilities like event dispatcher or timer. But what we're interested in is the Wi-Fi manager that's gonna help us connecting to my home Wi-Fi. Okay, so let me just quickly create instance of the Wi-Fi manager, and then what I need to do is to just do something like that, and there's some dependencies here. We need Wi-Fi multi, we need dispatcher, timer, and SSID and password. So SSID and password I'm gonna define as constants. So that's just this is just the name of the Wi-Fi network, and password is the password to connect to that network. Then for Wi-Fi multi, we need to include a built-in library and then create an instance of Wi-Fi multi. For the dispatcher is just event dispatcher, and for the timer is exactly the same. One small change is to convert those dependencies to pointers, because the pointers are actually required. Okay, and now after serial begin, there's actually gonna be one delay, and that delay is only to be able to for the IDE to catch up with the board, with the serial communication on the board. Otherwise, we would have to restart it every time when I connect, when I deploy something. Okay, and after that delay, what I'm gonna do is to just call Wi-Fi manager connect, and here I am supposed to pass a callback, and that callback is going to be called once the Wi-Fi is connected. It doesn't have to be successful though. There is a timeout defined. I haven't defined it myself because there is a default timeout of 5 seconds, which is enough. And once this callback is called, it's either connected or it is not connected because you know, the 5 seconds has elapsed, and then, you know, it just gives us the information what is the status at this point, and there's something we could do about it. But what I do usually, and what I'm gonna do now, is to just check if the status is WL connected. I mean, if it's not WL connected, and then I just print ln and information could not connect to Wi-Fi, and this is it. Then I do return, and that's it. That just prints out and doesn't do anything. However, this is designed in this way to for the developer to be able to handle like stuff like reconnection to Wi-Fi or trying different Wi-Fis or something like that. This library really still needs some refactoring, especially on this dependency side. As you can see, there's some dependencies that you have to create, and ideally you wouldn't have to do it. That would be done automatically, like with the default ones, unless you want to specify something else that meets the same interface. But you know, for the basic case, I would see this more like just taking SSID and password. But there's gonna be another video on the refactoring again, and then we try to do it together. I mean, I'm gonna do it and just create a video about it. Okay. Anyway, so yeah, we assume this is gonna be fine, unless this is not gonna be fine, and then the program is going to stop. So if we are connected, this is the moment where we want to start writing the code to create a web server, right? So let me show you Arduino IDE now. This example is the one from File Examples and ESP Web Server, ESP Web Server and Hello Server. This is the one. And there's gonna be some code I'm gonna copy paste from here. So I've got ESP Web Server initialization. That's gonna go here at the beginning. Then what else we need is essentially, yeah, so what you do with this server is pretty straightforward again. It's very similar to it's very similar to Express. So essentially, once you have the server defined here, instance created, you specify the request handlers beforehand. So I can do it like any place here, setup in the setup function. So let me give you an example. How did I call it? Let me just Okay, how did I call it? So that's called server. Yeah, it doesn't really it doesn't show up because I need to include it. This is important. ESP8266 server web server. So that's the header that needs to be included, and now I should be able to call something on the server. Yeah, and this is how you specify the handlers. So you need to pass a path that the server is gonna listen on, an endpoint. So this is just gonna be a slash endpoint. And then the second argument, this can be handler stride await if you don't care about the HTTP method. If you care about HTTP method, you need to specify it. So that's HTTP method, and then you have a bunch of methods to pick, you know, depending on the case. If it's get, usually you don't really need to specify it, as I said, but yeah, let's just do it. And then a function, a callback function, and inside the callback function, you can read the request and you essentially respond. So again, it's very similar to how the modern web server work. So yeah, again, let me just give you the simplest example that we could do here. And that's gonna be server send. So you're gonna send something straight away with code. This is HTTP status code 200. Content type, let's just make it text plain. And the third argument, this is a const char. That's gonna be our response body. And for the response body, I'm just gonna say okay. Another step that I have to do is to stop the client. I think this can be found in this example, and this is where it is not actually here. Server send. Okay, so this one actually is not required. Okay, so maybe there was another example where that was required. So you essentially need to do server.send 200 and okay. And okay, so this is how you define endpoints, but these endpoints are not gonna be called like by themselves if you don't start the server. So this is where I'm going to write some code in the onConnected callback on the Wi-Fi, because to start the server you need to call a method server.begin, and also on loop there needs to be another method. Let me just show you in this example. Server handle client needs to be called, as well as mDNS update. We're gonna add it as well. I've just realized this is also required. So what we could do is to copy this bit, paste it here, copy the mDNS header that is apparently also required. Okay, so we've got that, and we need to do that. However, with the timer utility class, we can actually start handling the connections, because this is what it does, right? Handle client really keeps handling the connections, incoming connections to the server. So thanks to our timer class, we could actually start calling these methods once the server started. So after server begin, I can use timer class and do set on loop, pass the callback, and inside this callback, these two methods are gonna be called, right? So they're gonna be called on loop. I also need to do timer tick here. So they actually gonna be called, because without tick is not working. That's another thing to refactor. because the tick is not really required. It is possible to use ESP8266 code to do the timer stuff, like, you know, to attach something on the loop, but that's gonna be another video again. Okay, so we got MDNS update handle client, and I think this is it. Let me just have a look at the example again. So yeah, for the simplest example, that seems to be it. I mean, we can handle that, and on not found, I'm gonna talk in a second. I'm gonna talk about it in a second. So we just say the server started, right? Okay, let me try to compile this. Okay, that's compiled successfully. Okay, so I'm going to deploy it. I'm going to deploy it, and while it's deploying, let me just explain the code again step by step. Right, so everything starts essentially here, right? We have all this initialization, the creation of the class instances, right? Like Wi-Fi multi, dispatcher, timer, server, Wi-Fi manager, and then everything really begins in the setup function. We initialize serial communication, then we set this endpoint, right? We make the server listening on this endpoint, which is the base endpoint, the default one, / right? And it accepts only HTTP GET method, and it sends back OK message with the status 200. Then we use Wi-Fi manager to connect to Wi-Fi. And once this is connected successfully, right? If it didn't connect successfully, we just send a message to the serial monitor, and that's it. Otherwise, this is quite important, we print out IP address of the ESP8266 connected to the local network. So that's gonna be the host that we want to call from Postman or from the browser. I'm gonna show you in a second. Then we have MDNS. This one is apparently required based on the example from Arduino IDE. And we start the server, the web server, right? We put server handle client method and MDNS update on loop. So they're gonna be called continuously on the loop function. And we just print out that the server is started. Okay. So now let's have a look at the serial monitor. Okay, in the serial monitor there is actually nothing showing up because the 5 seconds already elapsed. So I'm gonna reset it using the reset button on ESP8266. Okay, so what we see is MDNS responder started, HTTP server started, and address is 192.168.0.12. So let me show you how to call it in the browser. I'm gonna open my Chrome browser, and in the Chrome browser I'm gonna just go to this address, which is this one. And let me open it, and that's what I got is okay. So that's the actual response from ESP8266. So that's it for the simplest example, and now let me show you another thing that we could do here, which is something I've actually mentioned yesterday during the file system file upload video. There's also a link to this video in the description if you are interested. I was basically showing how to upload a file from the computer to ESP8266, and actually this is gonna be something I'm gonna do just now. So yeah, the next example is to demonstrate how to serve static files, right? So, you know, let's imagine the case you want to put a HTML page on the board, and you would like to serve it. So on your local network, users, like, anyone who is connected to your local Wi-Fi, will be able to open this website, and you can put some information on the website. For example, with the temperature sensor, right? You could display a temperature or humidity, or you could even do some other actions, like you could have a relay. You could have a device controlled by relay, and then have an interface, a web interface, that allows you to switch the state of the relay, right? So that's another idea. Or that could be a LED display, right? One of those I also showed how to work with couple of videos ago, and you could set some values there, right? So there is like many possibilities with the web server. Essentially, that gives you a control over some components connected to ESP8266, right? Because the method here doesn't have to be get, it can be post. You can accept some commands, right? And those commands can change something on the board, change some components, read some data, write some data, and so on. But yeah, anyway, to be able to do that, ideally, I guess it would be nice to be able to upload some sort of a nice interface, right? A small HTML page with CSS, or a small React application. And this is all possible with ESP8266 Web Server. And let me show you how to do it. So there are two ways, actually. One way, the one is the simpler one, is to use the serve static method. So what you need to do is to specify an endpoint. That can be any endpoint. I'm gonna call it static for now. Then a file system, a reference to the file system, right? So that depends what kind of file system you use. In my examples, I use littlefs because this is the faster one for, and also recommended for ESP8266, ESP32. So I'm gonna just pass this one. Okay, so that's gonna be littlefs. And then the third argument is the path to the folder in the flash memory of the device, right? So I'm just gonna put / again, right? Because that's gonna be the root folder. So yeah, this is essentially it. So now whatever I upload to the board is going to be accessible from the server. I haven't uploaded anything yet. I'm gonna do in a second, but let me just quickly show you what's gonna happen just now. However, before I deploy that code, I have to specify I have to add this setting to change the default file system to littlefs. And that setting is board build file system equals littlefs. Okay, so let's deploy that code. And I'm quickly gonna show you what's gonna happen. And after that, we're gonna upload some files. Okay, so that's deployed, and the serial monitor is connected, and everything started. So now I'm gonna go back to Chrome again. So that's the base endpoint, and we got OK. And let's try to go to static. And for now, what we got is not found static, right? Because there is nothing on the board yet. I can just, try to do index.html, for example, but yeah, this doesn't work because it couldn't find it. Okay, and the next step that I'm gonna do is to actually deploy some file to the board. So yeah, what I need to do is to create a data folder, and then inside the data folder, I'm just gonna create index.html, and that's just gonna be a very simple HTML document. with something like ESP8266 server, and inside the body we're just gonna have something like hello from IoT, right? Okay, and then to upload, maybe I create another file. Give me a second. So let's create a CSS file, and that CSS file is just gonna do something like body background color, and let's make it black, and then for the font color I'm just gonna do white, so we have something like a night mode, right, in the browser. So yeah, that's main CSS, and in the index, and then in the index I'm just gonna include this this style sheet, which is gonna be a link. So I think that's how this is done, yeah. And href is gonna be just main.css, right? So yeah, simple index.html with the style sheet. And now I'm just gonna deploy these files. So I'm gonna go to PlatformIO quick access, and then node MCU v2 platform, and let me show you upload file system image. So that's gonna upload the files. Yeah, there is some issue with that. Let me try again. Yeah, okay. Yeah, sometimes it's not picking it up first attempt, so you need to try a couple times. Okay, so the files are deployed. Before I test this, I've just realized, because we're using little fs and internally in the self static it doesn't start the file system, I'm gonna have to do it manually here. So once the server has started, what I need to do is to call littlefs begin, right? So that allocates all the memory and starts the file system. Without that, we wouldn't be able to see anything. Again, that would be just not found, like I've just showed you a few seconds ago. So this is important to not forget about initializing the file system before you use this method, right? The self-static. There's other one. I'm just gonna show you in a minute. And this one, we can actually start the file system, read the file, and stop the file system. So it might be slightly better on the memory allocation, probably. Okay, so that's done. It is deployed. Let me connect to the serial monitor. And you know, I'm just gonna reset this board because it was probably too late to see any serial data. Okay, yeah, so we've got the server started, right? So I'm gonna open Chrome and refresh this one, and this is what we see, right? Hello from IoT on the index.html. The CSS is also working, right? Because the background is black. But let me just quickly show you. This is the CSS file, right? So pretty straightforward. I'm pretty sure we could add more directories here, and then that would still work. I'm gonna try this in a second. However, one thing to note: if you go to static without slash, it responds with not found. You need to do a slash after that for the web server to pick it up and respond with the actual file. The default one is index.html, right? So if it's just slash, it tries to look for index. It looks for the index.html. If the index.html is there, this is gonna be the content that it serves. If it's not there, it's just gonna be not found, right? So there are two ways to actually access index.html, specifically index.html. Any other files, you need to specify the full path. Let me quickly check what happens if I add a directory here. So let's call it CSS, and I'm gonna move the main CSS to CSS. And then I'm gonna have to modify index.html and change the path to the CSS file. And what I need to do now is, okay, yeah, so now I'm just gonna have to upload it. And let's see if we can access the folders, if it's nested, right? If we can access it with the self-static. Let's see. Okay, so that's done. That should actually restart the board. So yeah, let me open Chrome. We should see the index.html. There we go. So index.html is working, and there is a CSS directory which has a main CSS file, and that works as well, right? So you can put the folder structure, any folder structure you could think of, and this is gonna be reflected with the self-static. So essentially the self-static works for those familiar with Node.js, with Express. It's very similar to how the self-static works on Express.js. Okay, and now let me show you another way of serving a file. It is sort of statically, but it's not based on directory anymore. It's more like streaming entire file. So let me show you how to do it. I'm gonna specify another endpoint, and this is just gonna be for the index.html. So let's do something like stream index.html, stream index maybe. Then the method is going to be get, and here what I'm gonna do, you know what, I'm actually gonna remove this bit, and I'm gonna remove this bit because I think that was enough for the demonstration of the first way of serving static files. And now let me show you a different way, which doesn't really force us to have the little fs, the file system initialized all the time, right? So this is another way where you can actually initialize it just for the call of the endpoint. And that's what I've actually done here. And now I'm just gonna have to open the file that I want to serve. So this is more like serving, you know, just a single file. I need to open that file for reading. That's gonna be index.html, and that's just for reading, so R flag. Then a simple check if the file has been opened successfully. I mean, if it hasn't, then I'm just gonna print something out. So that will be something like a could not open file for read. And let's just send 500, because this is not like not found. We expected the file to be there. So if we cannot open it, I'm just gonna, you know, send 500. The response content type, the body content type is gonna be JSON this time. Because yeah, this is essentially what we could do. We can send JSON. There's gonna be another video, separate video for parsing and creating JSON files, like, you know, more complex than this simple one, which essentially can be just a simple string literal. Let's just do could not open file. And yeah, semicolon here. If we can open the file, so that's for send, and that's it. If we can open the file, oh yeah, then we need to return. Don't want to continue. Wrong. Else is better, because I don't want to duplicate this line. So if we can open the file, Then there is a method on the server called streamFile. And streamFile takes a file, right? And the content type. So you need to tell what is the content type of that file. In our case is HTML, so I passed text /HTML. And we need to close the file after that. And we finish the little fs, right? So this is for streaming a single file. Okay, that's deployed, serial monitor connected. Okay, and let me open Chrome, and we're gonna go to, how do I call it? Yeah, the endpoint is stream index. So let's just go to stream index, and that's what we see, right? Hello from IoT. Again, the CSS is no longer served statically, so we just see it in with the white background and the black font. But that's essentially, you know, this is how you stream a single file on the web server. So yeah, streaming a single file or serving files statically, that's done. There's not really gonna be anything more on this subject. If you have any questions, please leave the comment. I will try to answer all of them. So yeah, so that's for the streaming / serving files statically. And this is where the part 1 ends. Part 2 tomorrow. So if you want to stay up to date with my channel and you want to get notified as soon as I upload next video tomorrow, I suggest hitting the subscribe button so it will happen. From me, this is everything for today. Cheers and bye.